So here is section 2, part B, the no calculator section of the 2017 AP exam from last year. Okay, so number 3, they give us this graph of f prime, and they tell us that the function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 equals 7. So this is important information because we can actually now write our function f as, since this is the derivative of f, we know we integrate to go back to f. So we have the integral, because we know this, we're going from -2x of f prime of t dt. So with this information, we're able to set up our function. It tells us the graph of f prime, the derivative of f, consists of a semicircle, 3 line segments, as shown in the figure above. So now we are asked to find the values of f of -6 and f of 5. So 2 parts to A. So we know in order to get f of -6, we're going from 0 to -6. But we know what f of -2 is. So I only need to go from -2 to -6. And my initial condition here from 0 to -2 is 7 f prime of t dt. And when I solve these things, I know really I want my smaller number to be my a to b on the bottom, so we can rewrite this as 7 minus from -6 to -2 of f prime of t dt. And so from -2 to -6, I have a triangle, and the area of that triangle is 1/2 my base is 1, 2, 3, 1/2 of 4 times my height of 2. And so I get 4 for this area. And so I have 7 minus 4 equals 3. So this is my f of -6. And now we need to find f of 5. So I'll do that over here. Again, we're starting from -2, write my function -2 to 5. And I know from -2 to 0, I have my 7 plus f prime of t dt. And so now I'm going from -2 all the way to 5. And what do we have here? We have semicircle, so this is 1, 2, 3, 4. So that's pi, half of 4 is 2, pi squared over 2. And I have this triangle here, which is 1, 2, 3, 1/2 of 3 times my height of 2. This semicircle is below the curve, so it's -2 pi, right, because 4 divided by 2. This is above my curve, so this is +3. So we have 7 plus 3 minus 2 pi, which gives me 10 minus 2 pi. And that equals my f of 5. Okay, next question. On what intervals is f increasing? Well, we know that f is increasing where f prime is not negative or above the x-axis. So I just look at my graph and I can see we're above from -6 to -2, and then again from 2 to 5. So we're increasing where f prime is positive. and that's from -6 to -2, and from 2 to 5. Right, wherever the graph is above the x-axis. Now it says to find the absolute minimum value of f on the closed interval, so this whole interval, and justify our answer. So remember, absolute min, any absolute extrema will occur at the endpoints or at critical points. So if we have some graph, the highest point here, look, is at my endpoint. The lowest point here is at my endpoint. Or lowest point could occur here, which is at a critical point. Highest point here happens at a critical point. So this is what we need to look for when we're finding absolute extrema. Endpoints and critical points, and seeing which one is the highest or the lowest of these. And so for part C, okay, so we know, at our endpoints, we already know what f of -6 is. We found that out to be 3. That's one of my endpoints. And 5 is my other endpoint. We also figured that one out. F of 5 right here is 10 minus 2 pi. And now where do we have critical points? Well, we have critical points at -2 and at F2, right? This is where f prime is 0. Where f prime is 0, I have critical points. And if I look at -2, I'm going from positive to negative, which means my graph is rising and then falling. So this would be a relative maximum. So I don't care about f of -2, it's a relative max. But here I go from negative to positive, so that means f is decreasing and then increasing, so this is a relative minimum. So we have f of 2. Well, what is f of 2? Let's go back to our formula here. F of 2 is, we have our 7 plus from -2 to 2, f prime of t dt. And from -2 to 2, I have my -2 pi. So I have 7 minus 2 pi. Oops, I'm writing that down here. 7 minus 2 pi. And so remember, pi is 3 point something, so this is 2 times 3. This is bigger than 6. So 10 minus something bigger than 6 is less than 4. This is 3. So this is already smaller than this. This is 7 minus something more than 6. So this is my absolute minimum. And now D. For each of f double prime -5 and f double prime of 3, find the value or explain why it does not exist. F double prime of -5. Well, this is if I take the derivative of the derivative at -5. Go to our graph of the derivative. So 2, 3, here is -5. Well, look at this. It's a line. And the derivative is the slope of a line at a point. I can figure out this slope. I could do rise over run, or I could take these two different points. But bottom line is, we have -6 minus -2 over -6 minus -2. So my slope here is -1/2. Right, so I'm just finding the slope of this line. I can use this point, -2, 0, and -6, 2. Right, I'm just doing f prime of -2 minus f prime of -6 all over -2 minus -6 which gives me 0 minus 2 over 4. That's where I got the negative 1/2. So I just figured out the slope of this line. And then f double prime of 3, so let's go to 3. Oh, look what's happening at 3. I have a sharp point. I know I cannot take the derivative of a sharp point. It's not locally linear there, so this does not exist. So we can say does not exist, and we can write not locally linear, has a sharp edge at this point.